Welcome back, everybody. This is going to be our final exam review part 2, question number 2. This one was previously a readings question. New streetlights will be installed along a section of the highway. The posts for streetlights will be 7.5 meters tall and made of aluminum. A city can choose to buy the posts shaped like cylinders or the posts shaped like rectangular prisms. The cylindrical posts have a hollow core with aluminum 2.5 centimeters thick and an outer diameter of 53.4 centimeters. Rectangular base posts have a hollow core with aluminum 2.5 centimeters thick and a square base that measures 400 centimeters on each side. The density of aluminum is 2.7 grams per cubic centimeter. And the cost of aluminum is about 38 cents per kilogram. If all posts must be the same shape, which post design will cost the town less? And how much money will be saved per street lamp post with the less expensive design? Okay, so here we go. So we're trying to figure out in this case the volume of each figure, and so we're going to take the cross section. By cross section, I started drawing the cylinder because they both have the same height. I'm going to draw the cross section, and for the cylinder, it'll be basically a circle and then an empty chord out circle. Okay, and the diameter of the outside circle is going to be 53.4 centimeters. But the inside, now here's the thing, if in this case the cylinder thickness is 2.5 centimeters, so 2.5 centimeters on each side means the diameter is cut by 5. Therefore, the diameter in red will be, in this case, 5 centimeters less, which will be 48.4 centimeters. All right, so what we're going to do now is we're going to, in this case, find the volume of each cylinder. And so this is our diameter, so each of these diameters, so this is the big diameter, and this is the small diameter, which means the big radius has to be, let's see now, let's take this diameter of 53.4 and divide by 2. 53.4 and divide by 2 to get 26.7. Okay, so let's put it down, 26.7. Right? And so the small radius will be half of 48.4 is 24.2 centimeters. So we're going to do now the volume of the big cylinder, which would be, in this case, pi times 26.7 squared. Now the height of this is going to be 7.5 meters, but we want to keep everything in the same units. And that's a key thing. So there are 100 centimeters in 1 meter. Therefore, our height will be 750 centimeters tall. Now the volume of the small cylinder will be pi times 24.2 squared times 750. And we're going to subtract the two of them. And so the total volume will be the difference. Pi times 26.7 squared times 750 minus pi times 24.2 squared times 750. Now, what's going to happen is this. To make it easier for ourselves, we see in this case they both have pi and they both have 750. So we're going to factor this out. And so the greatest common factor will be, so volume total of the cylinders will be 750 pi times 26.7 squared minus 24.2 squared. And I do this way instead of typing the whole thing out. It's much easier when I type in the calculator. So we'll go to our calculator, and so 750 pi, so we go to pi, and that's second caret, and now we have parenthesis 26.7 squared minus 24.2 squared. Again, we factor out the greatest common factor to make it easier for us to calculate. Okay? All right, so, oops, I think I left something out here. So let me, sorry, I made an error here. 24.2, can't forget that 0.2, very important. Okay? All right, so the volume of one of the lampposts, the cylindrical lamppost, will be 299,825.7489. So that's equal to 299,000. So 299,800. I believe it's 25.75. 25.75 cubic centimeters. Okay. So that's the volume of the lamppost, of the cylindrical lamppost, okay? Now I'm going to actually put this underneath here. I'm actually going to move all this down here. Okay, just move this down here. Because now contrasting, I want to find the volume of the lamppost that has a square base. And so we're told the square base is going to be 40 centimeters. But the inside part, the hollowed out part, well, again, 2.5 centimeters thick. So 2.5 and 2.5, if we take 2.5 off each side, we're going to get a measurement here of 35 centimeters. Okay, and again, we're doing the same things before. The volume of the big prism is going to be the base area, which is 40 squared times 750, and the volume of the small prism is going to be 35 centimeters squared times 750. Okay, and therefore the volume of the total for this figure will be, and I'm going to factor out the 750 because they both have 750. 750 times 40 squared minus 35 squared. Okay, let's take out the calculator. So again, we are finding out the volume of the prism, and usually it's base area times height, and the height is still 750. We factor out from both of them. We're going to now do 40 squared minus 35 squared. Okay, and so this is the volume here. And so we get, in this case, 281,250. 281,250 cubic centimeters. Okay, so now what we have to do is take a look at the difference of the whole thing. Let me just make this, let me move this up a little bit. See if I can move this up. Oops. Why is this doing this? Okay. Okay. So what we want to do now is we want to take, looks like the lamppost that has the smaller volume will definitely be the rectangular prism one, and we'll take a look at the difference though. Okay, so we have these values saved, and we're going to do the following. We're going to take this volume here of the cylinder and subtract by this volume here, which is going to be the volume of the rectangular prism, and we get a total of difference of 18,575.75. So the difference, so definitely we can say in this case, so comment-wise, we're going to make the following comment, that the rectangular prism, sorry, my typing's terrible, prism lamppost, I wonder if it's two words, lamppost, has a smaller volume than the cylindrical one. Oh, my spelling's terrible. Here we go. Cylindrical post. Okay. All right. So we say this. So we figure this out, and not only that, the difference will be in this case 18,575.75. So a difference of 18,575.75 cubic centimeters. That's our difference. Now, why is this important? Well, it says here, since the density of aluminum is 2.7 grams per cubic centimeters, and the cost of aluminum is 38 cents per kilogram, how much money is saved per lamppost? So we're going to take this amount. Now, this is 18,575. So we're going to now multiply this. Well, here's the thing. So we take our value, 18,575. Okay, 0.75. We're going to multiply this value by the density of 2.7. I believe it's a 2.7 grams per centimeters. Grams per centimeters. Cubic centimeters, actually, because this is cubic centimeters. And so, and then the cost. Now the cost is in kilograms. So here what happens is it's going to be 38 cents per kilogram. Well, instead of per kilogram, we'll do 1,000 grams, because that's what the units will be. So we have to divide by 1,000 as well. So we're going to take our value, multiply by 2.7 grams, and then multiply by 0.38, but remember to divide by 1,000, because our units, the cost is in thousands per kilogram. So let's see now. So we'll take times 2.7, that's our density, times 0.38, that's the cost per kilogram, but this is all in grams, so we have to divide by 1,000 grams. And so we are going to get, in this case, $19 and round up to 6 cents. So the cost would be $19.06 saved per post. Okay, so this was a little bit tricky because we had to remember that we were using different units. Okay, very, very important though. Okay, because we had 30 per kilogram, very important, even though we had 2.7 grams. So you had to convert our units as well too. So be very careful when you read. Reading is so important to be able in these problems, ladies and gentlemen. All right, so I hope this was helpful to you guys, and I hope that you guys please, if you have questions or comments, leave them in the section below. Feedback is definitely very welcome. Love to hear from you guys. All right, and if you found this video helpful, please give it a like. Appreciate that and all. And make sure to subscribe to the channel if you have not done so already to be notified. Turn notifications to know when new videos are added to the channel. And now look out for question number 3 coming up soon. And thanks for watching. Take care and be safe. Stay safe.